Hello, here we are again with another A-level maths video. This is a pure mathematics year 1 video on the quadratics chapter. Here we're going to look at section 2.5 of the textbook, which is all to do with the discriminant. So the discriminant then, this comes about by looking at the quadratic formula that you should be familiar with for solving quadratic equations. So to introduce ourselves to the topic, please pause the video in a second, try and solve the equations using the quadratic formula, and then restart once you've done everything that's there. Okay then, let's see how these ones are going to work. So the first equation that we've got here, I've already written it down, and I've worked out here by looking at the coefficients that the A is 2, the B is -3, and the C is -4. So the 2, the -3, and the -4 here. So using the formula, we're going to have minus b, which is minus the -3, which is just going to be 3, plus or minus the square root of b squared, first of all. B squared, -3 squared is +9, minus 4 times a times c. So 4 times 2 times -4 is going to become -32. And that's all over 2 lots of a here. 2 times 2 is 4. So just tidying that up, we end up with 3 plus or minus the square root of 41 all over 4. And I'll leave it like that. So hopefully you agree and you got that answer there. Okay, the second one. Now the second one, let's get that here like this. So same idea here. I've already worked out the A, the B, and the C. When you use the formula here, you should end up with minus b, first of all, which is minus -28, which is, of course, +28, plus or minus the square root of b squared, or -28 squared is a +784, minus 4 times a times c. 4 times 4 times 49 happens to be 784. Divide that by 2 lots of a. 2 times 4 is 8. So tidying that up, we end up with 28 plus or minus the square root of 0 all over 8. Now, of course, the square root of 0 is, of course, just 0, right? So this just simplifies to just a single number. There's only one possible answer we get coming out of here, which is 28 over 8, or cancelling that down, 7 over 2. So only one root to that equation. What about the last one then? Okay, so here's the last one here. Again, I've already worked out the A, the B, and the C. And if we try and use the formula here, we get minus b, which is minus -6, which is, of course, 6, plus or minus the square root of b squared. -6 squared is +36, minus 4 times a times c. 4 times 3 times 5 happens to be 60. Divide that by 2 times a. 2 times 3 is 6. And if we tidy that up a little bit, we end up with 6 plus or minus the square root of -24 over 6. So the question was, what happens when you try to use that quadratic formula to solve the equation? Well, here we've got a problem. Square root of a negative number. There's no real number which fits that. We can't square any real number on our number line to get an answer which is negative. So we kind of break down the process here, or the process breaks down here, and we can't go any further. And that means that this solution, sorry, let me say that again, this equation here can't have any real roots. There's no real number x which fits that equation. So keep all that in mind as we learn about this thing called the discriminant, because the discriminant of a quadratic function is defined to be the bit underneath the square root in that quadratic formula. That's the b squared minus 4ac. And it's this discriminant which is actually going to help us determine what kind of solutions we might get to the quadratic equation. Okay, we'll talk about that in a second, but before we do, we just need to make sure that you do understand this idea of the discriminant. So, quick fire question on the screen there. There's a quadratic expression there. What is the discriminant of that one, please? Okay, so hopefully this wasn't too difficult. The b squared minus 4ac, well, here's my a, here's my b, here's my c. So the discriminant, b squared minus 4ac, is going to equal the -4 squared minus 4 times 1 times 6 and that becomes 16 minus 24, which is negative 8. So the discriminant of this expression is negative 8. Okay, so let's see if you can actually make this connection yourself without me having to tell you. We've got our quadratic formula. I've put it on the screen there. How many roots will the equation have if the discriminant, that's the thing underneath that square root symbol, if that's a positive number? How many roots will the equation have if it's a negative number? And how many roots will the equation have if it's a 0? Have a think about it, pause the video and restart once you think you've got there. Okay, let's have a look at this and we'll relate back to the examples that you started off with and you actually already worked out. So if the discriminant, the b squared minus 4ac, that's the thing underneath the square root symbol, if that turns out to be a positive number like it did in the first example that we did in this video, then we're going to end up with two separate roots. Can you see that? We've got the 3 plus root 41 over 4, or the 3 minus root 41 over 4, and those are two separate real numbers, so therefore that positive discriminant is always going to lead us to two separate real numbers. So two, I'll write the word real roots. Don't forget that word real here. It's just telling us that, you know, the numbers are on our number line somewhere. So real means it could be positive or negative or 0 or fractions or decimals or anything which has a space on the number line is called a real number. Okay, what about if the discriminant was negative though? Well, that was actually our third example. Let's get that one up again. That was this one right here. So this one, we had a negative number underneath the square root symbol, and that left us with nowhere to go. You know, we can't take the square root of a negative number and get a real number answer. So therefore, that gave us no solutions or no real roots to that equation. And then if the discriminant was 0, well, that was the case in the second example we did. Let's pull that one up here again. And so we ended up here with the formula leading us to two different numbers. Actually, let me say that again. Not two different numbers, two numbers, but they actually happen to be the same number, didn't they? So because we had a plus or minus 0 here, we actually ended up going to the same number twice. So we could say here that that one had one root to that equation. And this is why the discriminant is actually very useful for us to know about, because it allows us to find out whether or not a quadratic equation even has real roots without us even having to solve the equation. We can just consider that discriminant, whether it's positive, negative, or 0, and that's going to tell us exactly how many real roots we have. So there's the result on the screen for you here. Make sure that you do understand what's there. Bit of terminology, which I just want to point out before we go too much further. In the third case, where the discriminant equals 0, then it has one real root, that equation. And there's a bit of technical language which you will often see. Sometimes you might see that the equation is said to have repeated roots in that situation, or sometimes equal roots. So technically, we sometimes think of it as having two roots. They just happen to be equal to each other. Okay, have you got the idea? Well, let's see. On the screen now, I've got a couple of questions for you here. I want you to not solve those equations, but I'd like you to use the value of the discriminant to determine how many real roots these equations have. Okay, pause the video and restart when you're done. Okay then, let's have a look and see how you did. So what we should have done is you should have first of all made sure that you recognize which is the a, the b, and the c here. So the b squared here is going to be the negative 4 squared, because b is negative 4. And then we have to subtract from that 4 times a, which is 2, times c, which also happens to be 2. So the a here is 2, and the c here is 2. Let's work that out. Negative 4 squared is positive 16. 4 times 2 is 16. So we end up here with the answer 0. And what does the discriminant equal 0 mean? It means that we have one real root. Or you could say we have equal roots or repeated roots to that equation. Okay, so only one value of x makes that true. All right, what about the second one? Let's see how you get on with the second one. Okay, so here's the second one here. Now, hopefully you didn't fall into the trap here, because I wrote this one the other way round. So the a here is negative 2, the b is 3, and the c is 5 here. Remember, it's the x squared coefficient, which is the a, the x coefficient is b, and the constant term is the c. So b squared is going to be 3 squared. And then from that, we have to subtract 4 times a, which is negative 2, times c, which is 5. Work out what that is. So 3 squared is, of course, 9. And then 4 times negative 2 times 5. I think that's going to be negative 40. So the discriminant equals 49. Now 49 is a positive number, so that must mean that our equation has 2 distinct real roots. Okay, do you see how important or how useful this discriminant is? Now, there's a couple of more things I want to do in this video on this. So the first thing I want to do is look at a kind of a question which is a very common sort of a question which we might meet here. The equation that I put on the screen here, we're told that it has 2 distinct real roots. And we've been asked to determine the set of possible values of that constant p, which is the x squared coefficient in the equation. So let's have a look at this one together, and I'll show you how it works. So what we are told here is that the equation has 2 distinct roots. So that must mean our discriminant, b squared minus 4ac, must be positive or greater than 0. So this is what we're going to use. Let's see if we can work out what the value of this discriminant is. B squared, well, b is negative 2, and negative 2 squared is, of course, positive 4. And then we've got 4 times a, which is actually p here, right? A is the x squared coefficient, so that's 4 times p. And then c is negative 7. That's got to be greater than 0. Tidying that up a little bit, we're going to end up with 4 minus, and I think that's going to be negative 28 times p. So I could probably write plus 28p there. Yeah, hopefully you're with me on that one. That's got to be greater than 0. And then I can just solve this inequality, right? So subtract 4 from both sides, first of all. And then divide 3 by 28. That's going to give me p is greater than negative 1 over 7. So any value of p, which is greater than negative 1 over 7, is going to give us a quadratic equation with 2 distinct real roots. Okay, over to you. Now it's your turn. Have a go at the question on the screen. Use the discriminants to help you and restart the video once you've got your answer. Okay, let's see how we get on with this one then. So here's our equation. We're told that this one has a single repeated root. So do you remember what that means? It means that discriminant, b squared minus 4ac, must be equal to 0. Okay, so what is the discriminant for this situation here? Well, b is 2, so 2 squared, 4. And then minus 4 times a, which is 3, times c, which is k. That's got to equal 0. Let's tidy that up a bit. So 4 minus, and I think that's going to become 12k equals 0. And here, a nice simple equation to solve. And if you solve that equation, you should have ended up with k equals 1 over 3. There is the answer to our question. Okay, now just before we finish this video, I'd like to see if we can just relate this back to these quadratic graphs that we looked at last time. So you can see how the discriminant might help us with graph sketching as well. So you can see I've just put a general quadratic curve on the screen here, and I'm going to change the values of a, b, and c as I go along over here. Currently, the value of the discriminant b squared minus 4ac equals 0. So that means that there is one real root to where this thing equals 0. And you can kind of see that there. There it is. It's just touching the x-axis there. Now, if I change the value of b, let's make the value of b something like, there we go. Let's move it down here to 0.2 or something like that. There we go. Something like that. There we go. And you can see here the discriminant is now negative. What does that mean in terms of the number of roots? Well, it means that actually it's not touching the x-axis anywhere. Let's change some of these other values here. You'll see the curve changes position, and there we go. The discriminant is now a positive number, and you can see that we've got ourselves 2 real roots here. It works for all situations here. So let's say we've got a value of a which happens to be negative. Here, look, negative discriminant not touching the axis. Let's move the value of b again a bit here. Up there, for example, like that. There we go. Positive discriminant touching the axis there twice. Okay, so hopefully you're seeing how the discriminant can help us answer questions about graphs as well. I'd like you to finish off this video by having a go at the question which is on the screen. You've been asked to use the value of the discriminant to determine the number of points of intersection that that graph has with the x-axis. So you're going to need to work out what the value of that discriminant is and then interpret it in terms of the number of roots that equation is going to have. Okay, over to you, see how you get on. Okay, here we go. Let's see how we did here. So let's calculate first of all the value of the discriminant, the b squared minus 4ac. And that in this particular case, the b is going to be -5. So -5 squared is 25. And then 4 times 3 times 7 is the 4ac, which I think becomes 84. So that means our discriminant turns out to be a negative number. It's -59. So we don't really care about the 59 so much as we care about the fact that it's negative. And that tells us that this quadratic will never equal 0. Okay, it has no real roots when it equals 0. So therefore, the graph has no intersections with the x-axis. And there we are done with this video. So that was our learning about the discriminant, introducing ourselves to the discriminant and why it's helpful. You want to get some practice with this. You want to make sure that you understand what the discriminant is and when we can use it. So please do make sure that you are consolidating this work by having a go at the questions in exercise 2G. However, that's it for this video, and I'll see you again next time.